Let us learn about polarization. To learn about polarization, we have to know about two factors, that is polarizability and polarizing power. Now let us take an example. Na plus Cl minus cation. This is cation of small size. This is anion of large size. Now, cation containing nucleus and surrounded by electrons consists of electrons. Anion, which is large in size, containing electrons which are loosely packed, and these electrons are far apart from this nucleus, and these electrons are loosely packed. These electrons are close towards the nucleus, and distance between these nucleus and electrons is less. When these two ions are brought close to each other, these electrons are easily distracted or distorted, but these electrons are not easily distracted or distorted. That is, the electron distortion in these cation does not take place because the distance between these electrons and nucleus is very less. This nucleus hold these electrons very strong. That's why these electrons are not distracted. This cation attracts this anion towards itself. Now, the distortion of these electrons takes place. Distortion means nothing but the tendency of an ion to get polarized or distorted is called polarizability. These electrons will be distorted. These electrons will be distorted. This distortion is known as polarizability. These anions get polarized and these electrons are distorted. That is, these electrons move towards this cation. These electrons move towards this cation and this anion gets polarized. This is known as this distortion of electrons by the anion. Electrons of the anion is known as polarizability. Distortion of electrons of anion is known as polarizability. These electrons are distorted because of this cation. The power of an ion to polarize or distort, the power of an ion, this ion distort these electrons. This distortion of electrons takes place by this cation. This cation distorts or polarizes this anion. Now, the power of an ion to polarize or distorts the other ion is known as polarizing power. This cation has polarizing power to distort the electrons of anion is known as polarizing power. Now, when this distortion takes place, these electrons undergo distortion and the electrons density that is number of electrons increases between this cation and anion, that is the electron density increases between this cation and anion. During this distortion, the electrons from the anion move towards the cation. The cation attracts electrons of anion. Now, while anion undergoing distortion, the electron density between the number of electrons or electron density between this cation and anion increases. Now, the electron density between this cation and anion increases. When the anion undergoing distortion, the force of attraction between the nucleus of the anion and these electrons decreases. As force of attraction decreases, the jet effective of this anion decreases. Because the distance between the nucleus and electrons increases, then the shielding effect increases here. As usual, the force of attraction decreases between these nucleus and electrons. And here the force of attraction between the electrons and cation, electrons of the cation and nucleus increases. Here Z effective decreases because the force of attraction between the nucleus and electrons decreases, because these electrons are far away from the nucleus and these electrons undergo distortion. Here the electrons does not undergo distortion and they are very close towards nucleus. That's why the force of attraction here increases. Here Z effective of the cation is more and Z effective of the anion here is less, that is Z effective decreases. Based on this polarization effect, we can know and we can learn about Fazan's rule. Fazan's rule is based on polarization. Fazan's rule is based on polarization. Now we can learn about Fazan's rule based on this polarization effect, and we know that Fazan's rule is used to know the qualitative approach of percentage of covalent character in ionic bond. Let us learn about this Fazan's rule in another video.